Dilligent. We have Claire Delauney from Farming. We have Tessa Lau from Dusty Robotics and Andrea Thomasz from Dilligent, along with our moderator, Rita Lau. Please welcome them to the stage.
Hi, everyone. Welcome. I'm very excited today to be here with three amazing roboticists. And they're from very different industries: agriculture, healthcare, and construction. And these industries touch a corner of our lives, but we haven't seen much adoption of robotics. So why is that? Is it because the customers weren't ready or the technology wasn't ready? Claire, why don't we start with you? I just learned that the average age of US farmers is close to 58 years old. That's really surprising. Why haven't we seen more robotics on the field?
Yeah, well, that's a very good question. I actually just literally come back from FIRA, which is one of the world's biggest robotics conference for agriculture. Turns out, yes, it exists. That's probably still not very popular because I think the agriculture is just at the point, I mean, the technology, I would say, is just at the point where it starts being at a good price point for agriculture and at a sophistication level that is enough to actually work in such a hard conditions. Because when we talk about agriculture, you really have to deal with the element and be outdoor, the sun, the dust, like everything that makes agriculture so hard and so less desirable, I guess, for the younger generation nowadays, because it's just a very hard environment.
Yeah, Tessa, I'm also curious. You're in construction, and your robots, there are about over 100 of them across the states. And they work like Roomba, go around the construction sites drawing blueprints. Can you help us make sense of the scale? Is 120 a lot? How far along are we in having robots on construction sites?
Yeah, so can you guys hear me? Okay, good. So I think we're just scratching the tip of the, we're just at the tip of the iceberg right now. Construction is a $20 trillion market globally. $2 trillion of that at least is in the US. And the problem that we're solving layout is just, it happens on every single construction project. And so 120 robots is just like not even scratching the surface of what is needed to actually fulfill the world's need for construction as we're going forward. And we're solving similar problems to Claire because the average age of construction workers in their mid-40s, they're all retiring. No one wants to come into the construction industry because it's hard. And so robotics is kind of the way of the future.
Got it. Andrea, and I think the healthcare system is facing a similar labor shortage issue, and your robots are now helping doctors and nurses across the country. Can you give us one example of what exactly they do in the hospital?
Yeah, no, I'm happy to. Yeah, our robots are called Moxie, and they do transport tasks in hospitals because like you said, there's a major workforce shortage in the US and worldwide of healthcare workers. And my background's in robotics, and so as I started learning about hospitals and how they work, it's fascinating the amount of stuff that gets hand carried around a hospital. Just the amount of walking to get medications, lab samples to the lab, lightweight equipment that needs to come from some supply room up to the nursing floor. So those are the things that our robots are able to automate, and then the healthcare teams get to stay with patients and do the more highly clinical work.
Right, and as far as I know, you're in robotics, and none of you have much prior experience in the industry that you're currently serving. Mm-hmm. How do you find out what farmers want, what construction workers want, and what doctors want for automation?
Well, I guess that's a good question, but in the end, I mean, as technology provider, the first thing you have to do is start working with people who are going to use the product. And I think that's nowadays that the base technology, I would say, exists in terms of hardware and software, because we have very cheap hardware and very sophisticated machine learning algorithm the key is really to embed the technology into process that makes sense for the user. And I think I'm super glad to be in this panel today, because I think we all share this love of like actually solving a useful problem that solves something on the field, and not just like take a hammer and just hammer everything that looks like a nail. And that's what's very fulfilling, and that's where I think we have a very good shot at creating something new.
Yeah, I mean, I think the most important thing is obviously listening to your customer. I think one of the reasons why a lot of robotics companies fail is because they want to build the hardware and they don't really think about how it's going to be used. And so when we started Dusty, it was always about let's understand construction, let's learn about the industry. I bought a hard hat. I spent 6 months walking construction sites before we even bought our first piece of hardware or wrote our first line of code, because I wanted to understand what are the pain points in the industry. And I continue to do that. I'm talking to customers all the time to make sure that what we're building is actually what matters to them.
Yeah, and you had a video that got viral recently.
Yeah, our customers love the product. Part of it is just making it so cute and approachable and friendly, but also obvious in terms of the value, that when anyone sees it, after 5 seconds, they immediately understand what it is, why it's important, and why they should care.
Yeah.
Yeah, no, I can't agree more with getting out in front of the clients and really understanding their problems. We spent the first almost year and a half of the company, we had one kind of prototype Moxie, and we would just take it to a partner hospital kind of one at a time, and we just embedded ourselves with a nursing team. Like, what do you need a robot like this to do? And just did a lot of listening, and there were the ideas that we thought, oh, robots should be like picking and placing things in a supply closet, but then the things that you actually get asked to do are different than what you thought it was going to be the real valuable thing in that environment. And then we build the product around the problems that they're telling us about. And then to this day, I think we continue to, I love to go out and just see how people are using the product and how people are interacting with Moxie. I think initially it's usually a very novel, people are running up to the robot, taking lots of selfies in the first couple of weeks, but I love going about 6 months in when it's just become part of their daily routine. And you can see kind of 2 robots crossing each other, and all the nursing teams are just like, yeah, those are our robots. That's what they do.
And you definitely learned a lot from COVID, which has changed. A lot of industries shut down manufacturing activities and created prolonged unemployment issues. How has COVID shaped your industry and robotics of your industry specifically?
One of the cool things that happened right after COVID was that I won't say it's cool in the sense that it was a tailwind for us. Construction workers stopped going to work because they didn't want to die. They didn't want to catch a virus and be in this environment where they were exposing themselves to potential harm. And so there was you think the labor shortage was bad for construction. It got even worse due to COVID. And a lot of those people haven't come back yet. They haven't come back to work. They went into a different industry. They went to go do something else that they thought was a better lifestyle for them. And so all of that has created these big impetuses for more robotics, more automation in construction, because they can't hire the people that they need. 90% of contractors cannot hire the people they need to actually grow their business, and that's a huge problem.
I think there's a similar issue in farming.
Yeah, so for farming, I think what COVID created is just accelerating a trend that was already happening, which is it's getting harder and harder to find labor. I would say that the climate change is creating more challenges for agriculture than even COVID. And so I think in agriculture in general, what's going to be very difficult is finding a way to transition and find a way to just automate more of the tasks that no one wants to do anymore, whether it's with COVID or without COVID. In any case, we have a labor shortage, and we're going to have challenges in the couple of the year coming into producing food. And that's why when we work with farmers, we really want to make sure we understand exactly how to solve exactly the pain point, the part that is the most difficult for them. So, for instance, when we talk about labor shortage, in a lot of industry, you can accommodate with a little bit of stuff or delay stuff around. In agriculture, you cannot. When the crop is ready, it is ready. You have to harvest it, or you lose a year, and then you are back to wait another year. And so we have. I mean, I would say agriculture is this kind of very difficult product where it's obvious that the task force and the lack of the shortage of labor is going to have a direct impact on the prices of the food we consume every day. Yeah.
Speaking of automating more tasks, we obviously can't talk about this here without talking about generative AI and deploying AI to most software and hardware. How are you planning to use AI or make use of AI breakthroughs in your robotics?
Everywhere. Of course, we're going to use it everywhere because it's good for PR and it's good for VC. But here's the thing. I would say generative AI is amazing, but we have to remember that everything that we see today and like the success of generating AI all happened because humanity took a couple of like cycles just to build the data. The writing, the drawing, the text, the speech, everything was already digital. When we're talking about an hospital or a construction site or a field, nothing is digitalized yet. I mean, we barely have GPS maps, and with the GPS maps, you're not going to navigate neither in a field, nor in a building, nor in an hospital. So it's kind of like underlying the gap that we have. To do generative AI, we need data first. And so there's really a big play for our industry into first finding the right modalities of sensor and the right format to store the data and later on do AI. But besides that, of course, we do AI. I mean, I guess.
Yeah, no, we're similar. I think we use a lot of the basis technology and kind of the generative AI machine learning algorithms that are gaining a lot of popularity today are the basis of a lot of our motion learning and perception algorithms. But like Claire's talking about, a lot of times instead of like big data across the entire internet, it's more important for our robots to focus on the specific data of this one environment that I have to be interacting with every day. And so we focus on the kinds of machine learning pipelines that let you, quickly gather a lot of data in a single environment and build the models for that environment.
Yeah, I'm fascinated by generative AI. I think it's like super cool. I don't see where we can use it. We're building a power tool. And the challenge with all of these AI systems now is that they're a little bit unpredictable. Like if you ever use ChatGPT or Midjourney, you don't really know what's going to come out. And when you're building a building, you kind of want to know what's going to come out. You don't want an AI in the middle of that telling you what to build. And so at least for the near future, we're not using any kind of AI in our robots. But I'm really interested in how they're going to transform other parts of the construction industry, the parts that are more creative, things like architecture.
Mm-hmm. And maybe one slight note. So I think in agriculture, where we see the most value for AI is really to basically infer data from sensors. So for instance, if you look at something by satellite imagery, it's really hard to know what it actually means. And so one good approach is to use a robot or something on the field to collect data and analyze what's going at the low level, at a precision level, and that you can learn it. And you can. This is possible to learn the cross-reference between sensors and make decisions based on that. And so that's we're talking about very particular use cases. Yeah.
So with these new technology tools, how do you envision your robots will become in 5 years down the road? Now your robots are opening doors for doctors in the hospital. What can they do in 5 years?
Yeah, in 5 years. Well, I think we feel like we're just scratching the surface of the types of, even if you just take materials management and logistics in a hospital, the kinds of transport tasks that we're doing today are just sort of scratching the surface of what we could be doing to really make sure that everything that's needed for a patient is there at the right time. And so that's kind of our vision, is to really take all of the kind of materials management of patient care off of the table. And that's going to be more dexterous manipulation, more integrations with software systems and data backends that kind of make the hospital run. But the kind of bread and butter is still being able to operate in a dynamic human environment. So hospital and farming and construction, you have people running around making the environment different every day, all the time, and creating that level of complexity. And so I think that's what I think is really exciting about these new environments that we're going to be seeing robots get into, is that as we start to tackle these problems of being able to deal with the complexity of people, it just unlocks so many more places that we can start to see robots.
Yeah, Tessa.
Yeah.
So they now help draw blueprints. Will we see robots helping people build buildings actually in the future?
Absolutely. I mean, so what I think is really exciting about construction is that it's on a trajectory where it's starting to become more and more digitized. It's the least automated industry on the planet right now. Actually, farming used to be last, and now construction is last. And so there's huge opportunity to introduce more automation, more robotics into the industry in order to improve productivity and make it more efficient. And so what I'm seeing is the trend of there's more and more, the vast majority of buildings now are being modeled in software before they get built, which means you have a 3D model of the building, you know what you want to build, but then when you go out and actually build the thing, it's guys using their hands, on their hands and knees, doing the work. And so what that means to me is that there's a lot of opportunity to create more robots that are using those building models as the instruction manual for how to build the building. It's like the blueprint in 3D tells you what the robots need to do. And so we're starting to do that just on the floor with automated layout. But as we go forward, I'm seeing the opportunity for more and more different kinds of robotics come to actually do the building work. And the reason that's important is because 10% of the cost of a building goes towards recovering from mistakes that get made by people. And so once we can start removing those mistakes and removing the opportunity for those mistakes to happen, you're going to get lower cost, more affordable buildings on time.
There's a lot of excitement in your respective robotics industry right now. And obviously you're here because you are leading the trend. So what hard lessons did you learn from testing your ideas on the field? Let's not just talk about all successes. We should have some interesting examples.
Interesting examples would be, in farming, I think that in general, farmers are actually very tech savvy, but a lot of interfaces and tools that we still propose to them are very complicated. It's a little bit like, when you drive a tractor, like you would be driving a plane from the 19 or the 18 even. There's a lot of buttons everywhere and a lot of things in writing, and it's just very complicated to use. And so I think one of the learning using the interfaces is how much, if you simplify the interface and make it like any other industry or more like a cell phone, a lot of people are able to actually do smart thing with the robot and interact at a better level. And I think in our trial, that's why our product is so popular. It's because it's super easy to actually instruct the robot to do something else than something that you would have pre-recorded before, and that everything needs to be straight and perfect and like millimetric. If you provide the right interface, the users are savvy enough to even find interns in or friends or the son of somebody or the daughter of someone else to write down application and to tackle the above layer. And I think for us, it's really, these 3 days of conferences were amazing because this is exactly what's going on. And there is a lot of farmers and a lot of young generation still want to try to make farming different if only they have the tools and the right interfaces and the right open standards.
Yeah, I think for me, lesson learned would be just the long tail of complexity when you're trying to put a product out into the real world. I think, for example, mobile manipulation. So we knew like manipulating on top of a mobile base is a hard problem, and we were one of the first companies to be out there trying to do that in a dynamic human environment. And one of the reasons that going into hospitals was really attractive is that most of the doors that you have to open are ADA compliant. You can push a button or you can scan a badge and the doors open for you. We're like, oh, that's amazing. That's going to be perfect robot environment. And so just that, though, you get out into the real world and you see all the different varieties of like where people decide to put an ADA button like underneath a hand sanitizer, and like where they decide to make this like badge scanner that you have to kind of like scan all the way over here and then run and go through the door. So I think now our robots are, we'll have more than 100 robots by the end of this year in a bunch of hospitals across the US, and already the fleet has opened hundreds of thousands of doors. And to do that, the fleet has essentially kind of learned and adapted about 50 different arm manipulations that are just about opening doors. And so I think if you'd asked me as like the academic 5 years ago how hard it was to get robots to open ADA compliant doors nationwide, I'd be like, oh yeah, that probably takes a summer. But it's really interesting the amount of data that you need to get in order to get some of these skills really working to a level of like production quality that it just works every day.
Yeah, Tessa.
So about a year ago, speaking of failure stories, about a year ago, we landed a contract to lay out the one of the warehouse distribution facilities for a major multinational retailer. It was the first pilot of its kind, and we brought the robot. Our customer success manager started working with the team on site to start laying out the locations of like the conveyor belts and the robots that would move the goods around and so on. And about a couple hours in, they noticed a discrepancy, and the field crews on site said, "I think your robot made a mistake," and they kicked us off the job site because they thought we screwed up. And so a lot of meetings ensued, and we dug into why it was happening, and it turned out we didn't make a mistake. The architects and one of the architects had drawn the model in a certain way, and some people had interpreted that incorrectly. And so it wasn't a robotic error. And so what we learned was that there's a lot of perception in the industry, and if you don't get the perception right, you have to manage that perception about the performance of your system in order for it to be perceived as correct and successful. Once you manage that, we are actually now doing all of the distribution facilities for this major retailer all across the US. There's over 50 of them just this year, but we had to get through that challenging phase, the learning phase, where their teams needed to understand what could our system do and where could all of the flaws be in their process. We exposed flaws in their process that made them better. But they didn't want to hear it at first, and so we had to coach them through that. Once they're through that, they're getting a much better outcome thanks to the use of the robotics.
Yeah. Andrea, I know you have news to announce today. You've raised a new round, and you also plan to triple your scale across the states. How do you plan to get there?
That's great. Yeah, thanks. We're super excited. Super excited that we were able to raise $25 million for the company and fuel our future growth. And a lot of that's going to come through existing health systems that we're in, wanting to kind of standardize and expand their footprint across their health systems. So, most hospital systems in the U.S. have between 5 and 50 hospitals as part of their system, and so over the last year and a half, we've mostly been landing relationships with new health systems, and now next year we're going to see a lot of expansion throughout the whole system. So we're really excited to see that repeatable success with our clients.
And Claire, you've been on both sides of the table. You were a VP at NVIDIA, and now you're an investor and CEO at PharmNG. Do you have any advice to anyone building robotics in 2023?
Yes, so I would say that my main advice would be, especially if you come from the technology and from the field of application, is that the budget that you think that you need to build a robot, it's going to be, you can take half of it, and that's going to be the supplement for bringing it to production. That's approximately that, because I think most of the time you realize very fast that between having the technology and having a good product market fit, it's very often like the very hard part is actually to finish this product market fit and to make it work really, really well for the customer. And you're going to spend a lot of money there and a lot of time and effort, and also a lot of expertise that is not technologic and that is really either on the sales part, on the partnership part, or on the job part. And so it's really going to come from another side of that has nothing to do with the pure technology. And I think that's the main success criteria for any startup in robotics, is that you have to be okay that it's not a technology play.
Mm-hmm.
It's really introducing the technology into a field.
Mm-hmm.
Yeah.
Yeah, and just personally, I really want to get this question across. Having grown up in Shenzhen, the world's capital of hardware, I am interested in knowing how the changing US and China relations have impacted the way you prototype, design, and manufacture your robots. Because a lot of the supply chain ties have been cut off.
Mm-hmm.
And like growing up, I see whenever the States has something novel that comes out, Shenzhen will, in a month, will have the same copycats at a fraction of the cost. And a lot of people will go to Shenzhen to prototype their products at a much faster speed than they could have done in Silicon Valley. Mm-hmm. Do you see any changes in how the way you make products because of that?
Yeah, good question. So we are lucky that we did all the prototype in-house in Watsonville. So it's south of Santa Cruz, where all the agriculture and farms are. So we have the manufacturing facility there. And one of the things that we really took care when we designed the machine is make sure that we use very simple and pluggable, plug-and-play hardware that you can swap parts. A lot of our parts come from the e-bike sector, just because it has very good physical properties for agriculture. And so we're very lucky that we control fully the design, and that we have an amazing sourcing team which is able to create alternative pipeline to be able to still keep up with the cadence of 5 robots a month. And so I have to say it's not always easy. You have to swap things and change battery, then we qualify everything, so it's still consuming. But so far, by keeping everything plug and play and modular, we are able to navigate that. But yeah, and as we mentioned before, I'm totally waiting for you to help us also source more robot parts for the community here.
Yeah, hopefully the situation allows. Do you see any impact? I know that you make your robots in the States.
Yeah, we still have manufacturing based in Austin, but we definitely had a similar kind of design to add a lot of redundancy for parts that were having really variable lead times over the last few years. So that was a big push for us.
Yeah, same. We manufacture here in the Bay Area. And one of the things that I learned over the last couple of years is that you need to diversify your supply chain. You can't be reliant on a single source vendor. And also, you can, one of the trade-offs you make is that you put in more engineering time in order to deal with different availability of parts. We couldn't get enough motors, and so you have a fleet with half this brand and half this brand. It just makes more complexity. It means you have 2 different SKUs, and if you have to do that for every single part, it creates a huge amount of complexity. And so that's the trade-off that you have to deal with when you're dealing with a less than optimal supply chain.
Right. And how about competition? Your industry is just starting to see traction, but do you see followers, copycats, challengers?
Yeah, well, I'll take that. We have competition. It's great. The reason it's great is because it validates our market. Being the only vendor of a particular solution, all of your customers wonder, well, is that really real? Do I really want to use that? Are you guys going to go under? But now that we have competition, the sales conversations are very different. Now the sales conversations are well, I guess there are 3 different suppliers for this kind of technology. Must be here to stay. One of those is a big supplier. And so people assume that this is a real thing, and now they have options. And so now it's not a question of, am I going to use automated layout or not? It's a question, well, of course I'm going to. Which vendor should I get it from? And we're the market leader, so that's why we're going to win.
Yeah, and for us, I can tell you, coming back from FIRA, there's a lot of competitors. But at the same time, I would say the sector is so huge. And there is a big difference between a 200 horsepower tractor and a 2 horsepower one. And we have a 2 horsepower one. And the reason for that is because there is we really after today the tasks on the farm that are still done by humans, not done by the tractor, because the place where the tractors are ruling is already taken, and it's going to be very hard to change the industry because it's very crystallized even in the distribution channel. So the way we position our product is really we push and bring the best of the autonomy that you can hope for a tractor, but on a very specific platform that can go along very close to human, and where the human-machine interaction is very important. And so it's really cool because we kind of have competitors, but in the meantime, not really on that segment. And this is where we benefit from everybody in pushing robotics to farming, but we are there with like an alternative that no one has for all the tasks where there's still a human right now, and that are not doable by the big tractors.
Yeah, I'm just noticing all the time. That's all the time we have today. I see a lot of common challenges and potential in your industries, and I really look forward to seeing where you go. Thanks for joining us.
Thank you.